Afternoon, everybody. Just gonna give it a minute, let people file in. Thanks so much for joining us today. I'll just give it another minute. All right, good afternoon. Good afternoon. All right, well, thank you so much for joining us today. Welcome to the 24th edition in our webinar series on the convergence of wetland science and technology. My name is Cameron Davis, and I'm the business development representative here at Ecobot. Today's topic is the U.S. Army Corps of Engineers Antecedent Precipitation Tool. We've got some great panelists with us today who will be introduced in just a few minutes. So just so you know, once we kick off, we're eager to have a two-way dialogue during the presentation. So down at the bottom of your Zoom window, you should see a Q&A button. Please use that to ask any questions that you'd like to have answered by our panel, and we'll field them directly throughout the presentation. So our host today is my colleague with nearly 2 decades experience as a wetland scientist and also the co-founder and chief scientist here at Ecobot, Jeremy Schewe. So I'll hand it off to Jeremy and kick it off.
Great, thanks Cameron, and welcome everyone. If this is your first time joining us on this free webinar that we've been hosting since the pandemic. Again, as Cameron said, I'm Jeremy Schewe. I've been working as a professional wetland scientist, ecologist, and botanist for the last 20 years. And I was super excited to help kick off this great program, both with Ecobot as well as this webinar. It's been a great way to bring our greater community together of regulators, consultants, land managers, and to facilitate a deeper understanding of tools that are available to us here in the 21st century and how they help to promote our workflow in determining where wetlands are, where streams are, the classification of those streams, endangered species, etc. So very excited for our registration today. We've got over 500 people registered for this, which is the second largest registration for this webinar series that we've had after the National Wetlands Inventory Mapper Database and National Wetland Condition Assessment updates, which we'll be doing again this coming December. So please stay tuned for that. I know there's still some people coming in. I'll say this one more time later. If you take your cursor on the screen and zoom down to the bottom, you should have a little toolbar that comes up. There's 2 windows that you can communicate with either the general audience or with us as the presenters and panelists today. So you'll see in the middle, there's one that says Q&A. If you have questions that are related to the tool, direct questions that are in respect to the subject matter that we're discussing today, please enter it into, click on that Q&A and go ahead and fill your question out there. If you have just more general comments, questions about tech behind the scenes going on with things, please just drop those into the chat and direct them to who most makes sense to associate those questions with. And Cameron will be curating those questions as we go. So without further ado, I'm very excited to welcome my fellow professional wetland scientists and panelists and presenters for today. One of the things that I'll say, we the Corps was very busy with looking at everybody's jurisdictional reports, and so they couldn't make it today. So we are presenting completely as consultants to you all today. And so we're going to have a nice roundtable of discussion for those of you who have participated in any of our previous 23 webinars. Typically, we have a very solid presentation chunk and then a Q&A at the end. This time, we're going to be having more of a roundtable discussion amongst the 4 of us as consultants with experience both in the field as well as with management and the utilization and how our teams are using the APT tool. So with that said, I'm very excited to have Nevin, Robin, and Olivia here with us today. Nevin and Olivia have been on at least a couple of webinars in the past. and this is Robin's first go with us. So Robin, thank you for taking the time to join us. And I'd love to give everybody a moment to briefly introduce yourself. So why don't we just start from left to right? And Nevin, bring yourself in.
All right. Thanks, Jeremy. Yeah, I'm Nevin Durish, a senior biologist with ESE Partners down here in Austin, Texas. I've been doing wetland delineations, permitting, endangered species work here, predominantly in the state of Texas over the last 16 years or so. I've been using Ecobot's tools for about 2 or 3 since y'all have been rolled out, essentially. Yeah, it's really exciting to be on here. Thanks.
Great, thank you, Nevin. Robin? Oh, you're muted, Robin.
Of course. I'm Robin Bedenbaugh from RES. I've been doing wetland delineations since 1988, so a few years. I have been doing delineations for DOD, DOTs, private entities for that whole duration. I sit on the state board here in Virginia that oversees the certification of professional wetland delineators here. So I have a pretty long background of being involved in wetland delineation, but my main role now is wetland mitigation and restoration. And hopefully I'll be able to talk a little bit about how it can be used to assist with that.
Great, thank you, Robin. Olivia.
Hi, I'm Olivia. I have a little over 3 years experience in the environmental consulting industry, working as an environmental scientist and wetland delineator. I think an OG customer of Ecobot. And just recently, within about the last couple of months, I transitioned to take on a role as the product manager with Ecobot. So that's where I'm at now.
Thank you, Olivia. And it's an honor to have you join the team and have another professional wetland scientist really help shape the future of where all this stuff is going. So thank you. So big picture, convergence of wetland science and technology. What are the implements that we're talking about? It's the crossover of GIS software, field applications, tools for gathering the data, GPS receivers, GNSS receivers that give us that high precision accuracy with utilization of more satellites, drone technology. All of these things are shaping our industry. And Robin, I imagine you've seen a lot of changes since you've been working on the scene here, you know?
Yeah, we used to use USGS topographic maps.
That's right. That's right. Yeah, when I first started, we had the topo maps, and I remember one guy, a PhD geologist, he was showing me how you could do area measurements on contours with dental floss.
Yeah.
Yeah, so good stuff. And so yeah, we've made some vast improvement. Yeah, van-sized GPS equipment, etc. So it's amazing the tools that we have available for us now. And it seems that the work is not going away. I don't know about everybody else, but this past couple of years since the pandemic's let up, it's just been mad. And so really just these tools are helping communicate with data more. But I think the other piece that's really crucial with this constellation of tools that are available to us is that there's also this opportunity to potentially influence policy more in the shape of how things will look in our future. So I really, really have a lot of faith in the future of how these tools are helping shape things. But how does it all work? And Doc wants you all to know that we are here to help you figure it out today. So our conversation today, of course, is around the APT tool created by the U.S. Army Corps of Engineers. So our goals today are pretty simple. Why use the APT tool? A little bit of background. Some of this may be a little bit of a reformulation, regurgitation for some of you folks. And for some of you, it might be a great amount of information and maybe get you utilizing it for your projects that are upcoming. We're also going to walk you through a kind of a multi-layered demo. And so what that's going to look like is each one of us is going to take on a different component of that, from how to download and set up the APT on your computer to how to run a simple query for, say, a wetland determination project, or a streams project. And then also we'll have a nice Q&A discussion at the end. So again, I'll use this as another moment to pause because I know we've got another 60 or so people that have come in. If you have a question that you want to ask the panel in respect to subject material, use your cursor, scroll down to the bottom, and there's a button down there that says Q&A. Please place your question in there, and I will do my best to field those questions to our team of panelists here as best as possible towards that latter part of our time today. If you just have general comments, more general questions that aren't really related to the subject matter, please use the chat button at the bottom of that screen as well. And if there's anything that is technical and should be flipped over, Cameron, who's working on the back end, will help remind you of that. So why use the APT tool? So we're heading out in the DeLorean out to the wetlands. It's time to do a wetland delineation. And are we doing the wetland delineation in a normal precipitation period? So that's where we're getting into today, is getting into the heart of why we would actually use this tool that the Army Corps of Engineers is recommending that we utilize for any WOTUS determination project. And why? Because it helps to support the regulators as well as us as consultants decisions around whether what we have collected in the field, our wetland sample points, our flow or ordinary high water mark for streams, whether or not that's being impacted by abnormal or normal climatic conditions. So let's get a little bit deeper into what that looks like and how the APT tool is helping us with that. So APT tool is site specific. You put in your coordinates or a series of coordinates or a polygon, and we'll show you how to do that here in a moment. So it's site specific. And then what it does is it draws data from various weather stations that are collecting precipitation over a 30-year period, and then gives you an output, which we'll look at as we get further into the data. We're going to take a look at what some of that output looks like, where the data is coming from, how many weather stations it's pulling from, how far out it's pulling from, etc. But again, the main focus, the why, is to indicate whether this WOTUS determination that you're either reviewing or that you're submitting for review was conducted, the field work was conducted during normal rainfall conditions, as well as within a typical year, because then that data can then be utilized as a way to support whatever argument that you're making as a consultant or as a regulator. So fairly simple in that context, but again, as we'll see when we get into the data that's available to us, both from the determination side as well as potentially from the planning and mitigation side, there's an ample amount of data available for us to pull from here. So here's specifically some of the sort of upper ends or the parameters of the data that were being provided. When we did the field work, is it being conducted in a dry season period? Is the water table much lower because of drought conditions? Actually, Olivia, you spoke a little earlier into a particular project you worked on within the last couple of years where you utilize this data for drought conditions. You want to speak into that a little bit before I move on?
Yeah, so we had discussions with the Corps on jurisdictionality of some wetlands, and we ended up having to do a deep dive into the drought conditions that were being experienced on site and within the watershed at the time. And it was pretty, I mean, I ran a date range to get a lot of information backing up the evidence that the drought conditions were persisting, and where we saw we had a lot of problematic wetland situations. So that helped us kind of confirm that those should be marked as jurisdictional because they're important to the area itself. And it was just a good conversation, a tool for the conversation we had with the Corps.
Great, thank you. And so one of the other things that we've been speaking about as a group here is just how did we gather this data before? You know, Robin, you were speaking into that a little bit earlier as well. Like, what were some of the hoops that you had to jump through in order to gather data for a site?
Yeah, I mean, there to this day, there's not a lot of data sets that we can readily access. That's the beauty of this tool. It accesses so many data sources that we don't have, you know, ready access to, and does it automatically and quickly. In the old days, I mean, all you could do was find the closest. When I started, there wasn't Weather Underground, so you had no Weather Underground station. So you literally had to go to a known NOAA weather station, and you had to use that data because that's the only data that was available to you. As you've noted, technology and data availability now is just mind-boggling. And we'll definitely show folks toward the end of the presentation just how much data this program is actually crunching for you and providing to you. It's pretty amazing.
Great, thank you, Robin. All right, so again, one of the results that we're really looking for here as supporting data to a jurisdictional waters of the United States determination. It's really what this tool is helping us to refine. And a lot of the Army Corps of Engineer districts are requesting, or in some cases requiring, that the output from running APT be supplemented as part of a report as an appendix. And so Nevin, I know you've been doing that since inception. Do you mind speaking into your process with that and how that looks, and what happens if you ever forget to put that in?
Sure thing. So for us in particular, it's not required in the districts that we're working in, but we're really using it as a tool to, you know, just supplement what the results of the data were. As I mentioned, working here in Texas, you know, we're in an area that is certainly prone to drought. We're in a big one right now, and understanding, you know, the relevance of, you know, recent rainfall, and especially, you know, and we can probably get into it a little bit more, the Palmer Drought Severity Index that we've used in the past it's not quite as helpful in describing what's going on in a particular area. It's a little bit more general. So having that data that's really tailored to a specific site and those specific dates that, you know, you were actually doing the delineation on certainly help out, you know, especially when you're referring back to on wetland data forms, you know, was this site inundated? Well, yeah, and it also received 8 inches of rain in the previous 30 days, you know, which puts it well into the, you know, above normal category, that sort of thing. So being able to refer to that, it's much more, you know, illustrative of what's been going on, you know, weather-wise at your site versus, you know, the little snapshot that you may get from the WETS tool or the Palmer Drought Severity.
And how typically are you putting segments of the APT output into your report, and what are you using? What are you putting in?
So we always include the actual output report, which you'll be going through in a little bit. We'll include that as an appendix. Beyond that, it's very much more site specific. Is this relevant to, you know, our results? You know, we see a lot of delineations where there's just not, you know, there isn't any findings that are really that heavily weighed by climate. You know, if we can pare down the report and keep it simple, we try to do that. But there are certainly cases where, you know, whether it be stream flow or wetland, you know, saturation, inundation, those sorts of things, it's really on an as needed basis. But I think part of the exercise of pulling that report during each of your, you know, as you're writing up a report, pulling that APT gets you into the exercise of let's take a quick look at what the weather conditions have been. So much in the consulting industry, you know, it's go out, knock those wetland points out and write it up, and you're not always thinking through what's been going on the previous 30, 60, 90 days at the site. and it gets you.
And
to
are
look at that.
you typically adding a paragraph of verbiage into your report as
Yes.
well?
Yep.
And in terms of additional level of effort for a project, negligible?
Negligible.
Okay.
You know, for the most part, you know, you've got a handful of different pieces of boilerplate text, you know, and you just discuss it right along with, you know, because we had always previously discussed the WETS outputs, and I think the WETS outputs are still relevant, and we can talk later about kind of the difference between WETS versus APT, because there are some differences there. But we had already talked about that, so we just integrated it into that portion of our report.
Sure. Okay, that sounds good. Robin, how about you guys from the res team? Like, additional level of effort, how are you all using it in your reports?
We haven't been using it in our reports. We've used it a little bit internally, just kind of partially getting a background for some of our mitigation sites, and you know, it can help you with interpreting your well data. You know, kind of looking at it. It just gives better site-specific information. So we haven't used it as much in reports. Our Nova district hasn't required it. You know, it's been more for internal information, just to help us understand what's going on in those sites at
Great.
that particular time. I mean, this, again, the beauty of it is it's giving you a 30-day rolling average beginning from 2 days ago. You know, it's and then that just, so it's very, very up-to-date information. And that we should all consider that useful for interpreting our wetland determinations.
Great, thank you, Robin. And so Liv, when you were working with Burns, were you all including it in the reports, or just in the reports when you had something that you wanted, you needed further proof or defense of your decision?
Yeah, I would include it in all of my reports. We typically would always have a section referencing the conditions on site, just as part of a general discussion. And in order to be able to say that, yes, this was a typical year or not a typical year, we provided an appendix of the APT result as the reference for that statement, basically.
Okay. And I just noticed Aaron Bars from Res also just threw in a comment in the chat, just saying that he has been adding the output to the annual monitoring reports for mitigation banks. So that's an interesting utilization that you know, can kind of add to the mitigation side of things. So great. Well, let's nosy on to the next portion of it. Like, just getting into some of the nitty-gritty details. I mean, for most of us in the environmental industry, most of us are using PC because of the other software that you were using, but the APT is for PC only. And it was developed internally by the Corps. And then it was decided it would be great to give access to the tool to the regulatory environment. So pretty excited that we have access to it as we do now. I believe that Robin spoke into this a little earlier. I alluded to it, but just very specifically, it's pulling data from regional weather stations. No particular number. It's going to pull from within a 30-mile radius and pull all the data that it can grab onto. And again, we're going to see an output of that when we get into our demo here shortly. I just have created a screenshot here of our particular output for a test project. And so basically what we have here is you've got your yellow band showing what is your normal range. And then you've got your peaks and valleys. You've got the blue line representing the data in respect to the last 30 days. And so you can kind of see where your project fell in terms of in that zone. So if, I don't know, can you guys see my cursor? Olivia, can you see my cursor? You can. Okay, that's great to know. So like some of these peaks here were obviously out of a particular range on January 9th of this year. we have a peak event here. So a delineation done in this period, you know, we would want to note that we're in a wetter period versus back here in late November, early December, we're in a particularly dry period at this particular sample point. So just some very basic results, which we'll see. So we're going to
Jeremy,
jump
real
into,
quick, I'd like to note something real quick on that as well. One of the more useful is actually that bottom line that you've got also those daily totals can be very helpful in kind of understanding individual rain events that occurred as you're walking the clock back. So
great,
that's one
thank
we
you,
use
Nevin.
pretty heavily.
Thanks for jumping in there. Appreciate it. All right, so we're gonna jump out into the demo here for a moment, and well, not for a moment. That's the next chunk of our time together, and just look at different options we have for running it. So let's head on out to the wetland here and take a look, and then we'll have our team on the backside working on the APT. So I'm gonna go ahead and close out my. No, I need to just change my screen share. Hold on. How does that work? Well, there we go. Do an escape. Drop it. All right, so there we go. Now my screen sharing again. Little hoop to jump through there. So we're going to take a look here at the downloading and the running of the APT tool. So Olivia, do you want to go ahead and bring up your screen? I think you can just grab you can just steal the sharing from me without, yeah, there we go.
Yep. Can you guys see?
Yes.
Okay, cool. So very basically, I've had to download this multiple times on various computers as I've had to switch out, which was always fun. It is definitely not the most user-friendly site or download process, but once you get the hang of it, it's pretty repetitive. So starting from the very beginning, if you just Google Antecedent Precipitation Tool, the first thing that comes up is a link to the EPA's website. If you click on that, you'll open up to this tab here, which gives you a lot of information on what the APT is, what it's used for, discussion of these other tools. So I saw in the Q&A we had a question. We can definitely elaborate later, but this article gives you some good information. It explains how it does everything it does and why. So if you really want to read a lot of words, you can go here. The key thing for downloading, you just want to scroll pretty much all the way to the bottom to this download the APT. So the first time I downloaded this, it seemed a little like, I felt kind of like I was going to get a virus on my computer from how it looked, but it works and it's correct. And that was the beta version. And now that this new version is released, it's a little bit cleaner. So you can click on either of these links, and this is going to take you to the GitHub repository. And that is, it will look like this. You need to have 7-zip on your computer to extract the document. And it's just 7-zip is a method for downloading or extracting really large data sets. So if you click on this link here, it will open up a tab that this is where I started to get scared and was like a little bit, seemed a little bit dodgy, but you just need to know for a PC what system you're operating on. So this is, could be easy to do if you reach out. You can either reach out to IT if you're not sure, or you can look at it through your settings. I have a Mac operating system, so I actually downloaded this one. And then I never know how to make this go away. At the top, pull this down. So I just downloaded this, and this is your extension. This is your 7-zip extension. So this is just downloading the software, or not even the software, but the extension in order to extract the antecedent precipitation tool from how it's posted in this site called GitHub. So then you'll go down, and these are the assets. So what you actually need to download is this antecedent precipitation tool.7zip. So that'll download, and they recommend downloading it to your, or extracting it to your desktop. So if you click here, it's just gonna set up a download, and then I extract that to my desktop, and you'll get something that looks like this as just an open folder. So it's got lots of various folders inside of it. It's huge. There's all kinds of stuff, extensions, and more than you want to go through. The easiest way to get to this is to just search main, and it should be the main. I'm actually going to download this new version of it. It's going to be main _ex.exe, and this is the tool itself. So that's how you open up the tool, and once you just double click on that, it'll open your window up, and you'll be able to see what Jeremy sees when he takes back over. If there's any questions about this, we can chat later, or some people said their IT department did it for them, and that's great job. Great IT department.
Well done.
Yeah. So I will cede my screen sharing.
Here. Okay, can everyone see? You've got beech leaves with gold? Okay, great. All right, so I just keep the tool open, or not open, but sitting here on my desktop. So I'm gonna go ahead and just pull it open so you can see what the initial screen looks like. For whatever reason, every time you go in, you have to agree to make this agreement. Then you get this awesome Pac-Man version. And I think it'd be neat if we had a little Pac-Man that kind of like went through there and ate that. But anyways, that's neither here nor there. Basically, you've got this little window here. So I'll put it in the middle of the screen just so that it's easy to work with. So you can come in here and just drop in your sample point or point centric, and run a query from here. But there's also a few other options you can play with over here. You can either download for a particular HUC region, or you can do a custom polygon. So you could try putting in your project area and work with that. I've never actually worked with the polygon, and I'm not sure if anybody else. Nevin, have you worked with putting a polygon into this for any of your projects?
I have. It's been a little while, and I think the conclusion I came to for most typical development projects is just the size and scope. Unless you're dealing with a really long linear project, something like that, or you're looking at a watershed above your site, it's really not. I don't find it to be as useful. But I would consider it maybe in the watershed perspective, hence why they have the HUCs also listed as options.
Great. So if you're doing just a single point, after you've put your point in, you can just come in here and tell it when you want to run the query for. So I'm going to run this for a project I did back in March. And then you just hit the calculate button. Now it's going to run, it's kicking everything back over to this screen on the left. And now it's running a query. So we'll just, and I wanted to do this live just so you can kind of see how the real time for this works. And so down at the bottom of the screen, you'll see where it's queuing the stations that are within 30 miles. And so now it's starting to pull them in, and it'll just keep grabbing them. And again, Robin's going to talk a little bit more about these here shortly. And then, another moment, it's going to create the PDF output here in a moment. So it's telling us, oh, there we go, it's picking up. So I've heard where some queries can take as many as 6-7 minutes, sometimes as short as just a couple of minutes. Robin, what's been your experience with timing on some of these? If you're talking, you're muted.
Sorry about that. It's usually anything from just under 4 minutes to 6 minutes.
Okay.
It's incredibly fast.
Yeah, and you know, just to give this some perspective, this is pulling from data sets from, like, I mean, you were saying, Robin, you think some of these could be just meters, like on somebody's farm that has an automatic meter, like it's pulling from all over the place.
Yes, that's correct. And that was one of Tom Dombrowski's questions. The output, the graphical output that you get shows only the weather stations that they're pulling the 30-year average from. The blue line is the 30-day rolling precipitation average. And it is, I ran it on several sites just before, and it's pulling from more than, you know, as much as 200 data stations that are within 30 miles. And it actually shows you how many miles away each station that it's pulling the data from to get the actual precipitation, 30-day rolling precipitation data from. And I mean, they're right on top of each other. And that's largely because nowadays, literally every single farmer is hooked, has precipitation gauges on their farms that are linked to a data system. So all the other farmers can see, well, Joe got 3 inches yesterday, I only got 0.5. And that's the kind of data that this is able to pull from that you and I can't readily access. Right. So it is actually very, very accurate data for your specific location, because it's literally picking up stations that are hundreds of meters away, or a quarter of a mile, or 1.4. And when it averages 137 stations that are, the majority of them are less than 5 miles from your site, it's giving you a really, really accurate precipitation log.
Yeah, it's not letting me hover over where the stations are here. It keeps throwing me back down, but you can kind of see, like, some of these just, if I can get to stay for more than a moment, some of them have specific locations attached to them. Some of them are family names. I imagine some of them are still, I mean, typically where I was pulling data from prior to this was having to go and hunt down the closest airport. And, you know, typically they had really good data sets. So again, just good for everybody to see the real time for this, as we're kind of talking about some of the details around it. I mean, while we're looks like we still have a couple minutes, Robin, you want to talk further about some of the other bigger data sets that we might be looking at here?
Yeah, sure. If you want to, how do I share?
Why don't you go ahead and just rest the screen share from me, and then you should be able to just claim it. If not,
I'm not sure. Yeah, I'm sorry.
Okay, I'll stop.
Yep.
We'll let that.
All right. Here we go. All right. Can you guys see the basic printout there? So this is what you get when you come up. Before you run your tool, you get this. But when you start running it from your little selected option, it starts running this data set, and it'll tell you at the end, you know, it took this long to assemble everything. The very first thing that's really coming up here in data is it's showing you every single station that it is pulling from data, precipitation data from, and exactly how far away it is from your particular latitude and longitude that you input. So Charles City, 4.1 miles, 0.2 miles, 0.5, 3.5, 5.4, 1.7. So it gives you all this data. Literally, it's averaging all of these. And in this case, it was 137 that were found nearby. And this isn't the 30-mile radius. This is all the stations. All the farthest away any of these seem to be is less than 10 miles. I know that the 30-mile radius is for those major weather stations that they collect the data for the 30-year averages from. But literally, this is all the ones they found in the area that they averaged. And so it is actually incredibly accurate for the rainfall in the past 30 days for your site. And you can roll it to whatever date range you want, so you can look at 2 months ago, 3 months ago, 4 months, anything you want to do. And it's collecting from so many data stations that it is really incredibly accurate.
Robin, while you're here and talking about switching date ranges, you want to just show what that looks like when you...
Well, yeah. Here was the other thing. You
Okay.
wanted me to talk about the data.
Oh, yes,
So
please.
there's two things that get generated by this whole process. And it gets deposited on your computer in a folder called outputs v1.0, and then the actual lat long coordinates that you entered. In that is the Adobe PDF printout that you received, which it'll come up on your screen automatically, but it's also saved here in this file. And then in the station data, this actually has the data, all of the data that was used for the rolling 30-year, for the 30-year average. And in many cases, the data is like...
I'm going to pause you there for 1 second, Robin, and just tell everybody the PDF output from the query that we just ran just completed. I just got a signal for that. So okay, just for timing, continue.
Yeah. So this data you guys can mine for any number of things. And the beauty is it takes all of those data sets and it converts it all for you. So if a particular data set is in centimeters instead of inches, it converts everything to inches for you. And it's just a massive, massive amount. Here's the merged stations converted data. That's converted all the data from these different stations over a 30-year period. And in this case, it's from 1990 to 2 days ago in 2022. So it's actually, pretty robust. And so this day, what I do is, because this is going to, a particular folder, if I've got a project, I just make my own folder for the data here and just copy these and put it into my project folder so that I've got it readily accessible to me instead of having to try to search all over the hard drive for wherever APT tool has stored this particular file. So, but yeah, it's a massive amount of data. It's probably unlimited uses, we could find for all of this data that it has amassed in just minutes.
Yeah, it's pretty amazing. Go ahead, Olivia.
Jamie, yeah, I was just going to show. So I'm responding to one question in the Q&A right now, but I want to share my screen to show you a couple of the resources that I mentioned, excuse me, before. So this main page that has the information on the APT, if you go down to the bottom for the contact us, this email is used for just the general use of APT. And then there's also one for if you have issues with your outputs and exports. These would be more of the technical issues that you have, but questions about downloading and just how to, when it's available for Macs, that's the question I was looking at. That might be a good one to ask through here, or Jeremy gave you a contact to reach out to as well. These are also good resources, and so I have them pulled up. They have a short video on that was posted on how to do the download and use it very briefly. This is a lot more detailed option that we're going through. This is an official document that gives a full technical use guide. And then this is a handful or a helpful small fact sheet that also gives some resources. And all of those are linked from here. So just as a heads up.
Great, thank you. So, so Anna Touchstone has asked, how do you determine whether to use a point analysis versus one of the HUCs or etc.? Nevin, I'm going to give it to you for that first.
Yeah, I was looking at that one actually. So my main consideration there would be what information are you trying to glean from the APT at that point? If you're dealing with, a river or something like that, and that's capturing that entire HUC, you may want, if you look at the flow, that sort of thing, then you do want to consider the rainfall in that entire HUC, not just what's happening at that point. If you're looking at, isolated wetlands, that sort of thing within a small site, then I would definitely tend towards just the site-specific one there. But really consider what information are you trying to glean from that, not just what rain fell on your site, but what fell upstream of the site, if that's important.
Great, that sounds good. And from the mitigation perspective, Robin?
Yeah, I mean, there's lots of ways you could use this data. You can use this data. I mean, first of all, understanding the hydrology of your site that you're going to be doing, hoping to do wetland restoration on is important. You need to know how the water behaves in the soils on the site. You need to know about the groundwater, and you need to know how much precipitation overall. And so in planning for these sites, if you're in a peatmont site that has really tight loamy soils, fine textured soils that predominantly moisture runs off of rather than saturates in, this can be great for getting better information on site specific precipitation patterns. So you can kind of model better, how much water you expect to run off, adjacent property onto your mitigation site, or, from upslope down. You can use it in sites, especially in like mineral flats, flatwoods sites where groundwater precipitation recharges groundwater during the winter, but ultimately the hydrology of the wetlands is driven by how high the groundwater gets and for how long that groundwater stays that high into the growing season. This can be useful in evaluating your mitigation well data from such sites, so that you understand if you had a really poor precipitation during the winter, which is the groundwater recharge period, maybe it explains why your wells didn't meet as long, into the growing season as not. There's a variety of uses you could use to help you interpret, mitigation stuff.
Yeah, I imagine you could pair it with, old school piezometer data too, and just have numbers side by side to look for patterns that. Yeah. Okay, so I want to pivot here and continue in that we've got a lot of great questions coming in. And so one of the things that you leaned into earlier, Nevin, was in respect to comparing the utilization of, say, WETS with APT. Would you mind just speaking into that a little bit? And then there's a specific question from Schewe. I'm imagining that's their name. Schewe is asking that we'll dive into here in a moment too. But if you could just do a little side-by-side comparison, that'd be great.
Yeah, I think the main difference there is WETS also looks at the growing season, and this doesn't take any account of growing season that's going on. So I think they really complement one another. And for our reports, for instance, we still pull the WETS data for every site that we have. And like you said, it's a little bit more distant from the site. It's a weather station data from the nearest airport usually. That type of thing. But I do think that the two data sets complement one another. And with WETS, I'm usually focused more on the growing season side of the output, and then rely on the APT for precipitation.
Yeah, so Schewe's question is really in respect to, it sounds like they are doing delineations in a lot of very urban areas. And so from urban areas, when you're doing a 30-mile radius, it's pulling from, well, she's saying 200 plus stations. that's interesting to think about, because when you're operating mostly in a rural area, that you're probably going to be far-fetched to be able to actually pull in enough stations to give, even with, as Robin was saying, more farmers having monitors on barns and other outbuildings and things like that. So any thoughts on that, Nevin, like urban versus rural, and like how this tool may be affected in that way?
Not particularly. I mean, we know there's some heat island effects and that sort of thing with
Right.
urban areas that could cause, substantial differences in, if you're looking at a 10-mile radius versus a 30-mile radius. I'd say look into the data and know the data that you're working with. I know that's not the most satisfying answer.
I mean, in some ways, it almost seems to me like, at some point in time, although some people say we're already there's already so much data garbage just floating around that you got to sort through and know how to like get through so that you can tractor beam in the actual information that you're looking for. It seems to me that in regards to environmental data, that in many regards, like we're behind the curve, we don't have a lot of data. And so some regards, maybe having more stations pull up from an urban area will give a more statistically provable data set. I mean, so I don't know. I think that we can kind of close that one out, but really appreciate jumping into to that comparison between the two. Someone had asked how frequently APT updates come out, and I don't really have a good answer to that one, but I thought it'd be a good thing to discuss here. It looks like Nevin, you're ready to jump through.
I was going to say, it does check for updates when you open the tool, and it does automatically check for updates. I don't know if that only includes minor updates or not. I haven't been involved in that deep, but it does check for updates periodically.
Okay.
Yeah. And I'd like to just for a second go back, Jeremy, to the accuracy of data. Remember, these are tools,
Right.
and they're models. Your wet stuff is not based on data that's probably any more accurate than some of these stuff. And granted, a lot of the data that, and let me, two things. There was one question in the chat that said, the 30 year is coming from just those 5 or 6 NOAA weather stations that have that data for that many years. But your APT is picking precipitation for your specific location only from so many stations right around that site. Like I said, I haven't seen any results yet showing that any of the data stations that it uses for the precipitation, antecedent precipitation, that are for more than 9 or 10 miles away. Most of them are within 2 or 3 miles or less. And if you think about it, yes, of course, weather stations installed on a farmer's land, they're not all using the same QA/QC and installation or maintenance, but you remember, it's critical to their livelihood. They have to know how much rain they've got. They've got to know whether they've got to irrigate. They've got to know how much they've got to irrigate. So by and large, it's better data than we have from any other source. So I'll say that to the right. Person that says, I question, the accuracy of it. Well, yes, certainly. But you've got, 140 stations that are within 10 miles that is averaged all that data from, with most of them being from less than a mile away or 2 miles away. It's better than anything we've had previously, by far.
Yeah, and Robin, I want to just continue in this thread with you, but Leah Beckett's asking, are the input data sources vetted? Is there some sort of QA/QC process, especially since it sounds like a lot of them are coming from private data sources? I don't have an answer to that question. I didn't know if you would.
I don't either, but I think that program that the farmers, it's basically, I think it's through NRCS or something, it's with the assistance of at least some governmental agency. They're not just doing it on their own. It's they're signing in to some sort of system and agreeing to have their data, automatically uploaded. So these aren't little plastic rain gauges that they walk out and read. These are actual logging rain gauge loggers, that are you would assume had some level of QA/QC put into their construction when they're built. Whoever built them and supplied them, there's some accuracy level that they're tuned to. So I personally think it's pretty darn good.
Yeah, I just saw Tom's response there. Yes, I guess something is better than nothing, right?
Yeah.
So yeah, exactly. So all right, well, we're just starting to run down on time here. I'm looking to see. Okay, here's one just in respect to discuss if 30 years of data collection are needed for APT tool to use. I don't know that I have anything on that either. Robin, I don't know if you see that question from Brian Miriam. It basically says, I find sometimes APT bumps a more appropriate station because a less appropriate station has more data.
Yeah, I think that would be a question for the core person who basically put this together, but
yeah.
Yeah.
And what's his,
I think that they by using as many stations as there's 5 or 6 stations. I'm sure that's why it's using 5 or 6 stations in that area, is because it's accounting for some that have gaps of, missed this 3 years or whatever. And I think it's basically the average of those stations. So I think when you look at those, you could go do your own data dive and go look to that specific weather station and see what their data looks like.
Yeah, and I'm seeing Jake Muffley keeps asking a question in respect to evapotranspiration. So yeah, this is completely just pulling from precipitation.
Yeah.
Yes, evapotranspiration makes a major difference in how, certain species transpire more water than others. I mean, that's a whole nother study here. So
and that goes and that goes into the best professional judgment in making the wetland delineation call.
Right, exactly. So sometimes we just have to roll with that.
Jeremy?
Yeah.
I ran a date range that I can pull up quick if anyone wants to see that. And then I also just wanted to point out that wherever you save your tool, when you extract it and download it, there's a folder inside called outputs, and it saves every output that you've ever generated. So I would recommend when you go in, right when you run it, go change the name of it to whatever your project is or the date you ran it, because it'll just give you, mine is v1_0_20 with the lat long that I used. So all of that's available and keeps it in one place.
Great. Well, we're nearly at the end of our hour here. So first and foremost, really want to thank you all for participating as panelists. I mean, a lot of great input. Really enjoyed the live discussion here. Great way to facilitate this. I wanted to just put a quick plug in. The next webinar will be October 20th, and that's going to be focused on mitigation banking tools and tech. And so we should have a great panel of presenters for that. And so before we close out, just would like to offer all of our excellent panelists here a moment for closing remarks. So we'll start with Nevin.
Yeah, I actually wanted to chime in on a remark that Justin Kinzinger with EPA had about using it for historical reviews. You can go back in time with it and see what was going on if you're looking at an old delineation or something like that. Really handy. Same with aerial photographs. Just make sure you know what the date was from the aerial, but really handy there.
Thank you, Nevin. Olivia.
I thought I had good experiences with this tool, and I came from pulling raw data from NOAA's sites to try and get normal year averages. So I will take this over that any day. And with all the questions of using it as the sole precipitation, I would just say use all of the data that you can to get the best picture of what's going on at the site. So this is just another tool to do that. Continue to use all the other tools that you've already been using.
Definitely. And, you know, sometimes it's like when we make a tool that's really good and it works, then we want it to work better, right? And that's the nature of the human condition. So we will continue to build on what we have. So Robin, closing remarks.
Yeah, so from the mitigation standpoint, you know, in our desktop initial reviews and site searches for properties, you know, I use Google Earth Pro and the historical imagery religiously, you know, and one of the things that this can do is every image that you go through has got the year and the date, the time, June of 2011 or whatever, and you can go back then and run that date for that site, and in 5 minutes, you know exactly what the precipitation was that year for that signature you're looking at. And it certainly could be useful as a supplemental data for you to help pick a better site or the best site. Yeah, we'll be using it more with our mitigation sites, as Aaron from our Houston office mentioned. They're using it in Texas for their mitigation reports, just as supplemental data to include in the reports, so that the regulators that are reviewing it know what the conditions were that year. So I think it's a pretty interesting tool. Definitely underutilized. I think some of that had to do with COVID, and not a lot of people knew it was out, and it was a beta version. And I think someone asked about the updating, and Nevin said, yeah, it automatically looks for the updates. But, you know, I didn't know that the new version had come out in February of this year. But yeah, no, I think it's got a lot of uses for those of us in the profession, the wetlands field. And hopefully a lot more people will start using it.
Great. Well, Robin, thank you. Nevin, thank you. Olivia, thank you. ESE and Res, thank you as companies for having your staff out in support of our community, growing its knowledge base and what tools are available to help with our WOTUS determinations. So thank you everyone from the participating audience. What a great round of questions we had coming in there. And we'll look forward to seeing you in October. All right, take care everyone.
Thanks for hosting.